Hello friends, this is Shalu. Welcome to CPP Flix YouTube channel. In today's video, I would like to explain about STD forward, which was introduced with C++ 11 standard. Before looking into STD forward, let me ask, what an STD move function do? An STD move conveys an unconditional cast to an R value. It means it simply convert an L value to R value. While the use of std forward indicates a cast to R value only for references to which R values have been bound. Here is the syntax of std forward. It's a template function in the standard library. An std forward simply forward an object to another function in a way that it retains its original lvalueness or rvalueness. This allows the rvalue arguments to be passed on as R values and L values to be passed on as L values. And this scheme is called perfect forwarding. Actually, this perfect forwarding is the use case of std forward function. It will treat an L value argument as L value, also an R value argument as R value by retaining the valueness of the argument. Let's go through an example which will make it clear. So we have a function fun in overloaded form. Here this overloaded fun version will accept L value integer argument, and the second overloaded format will accept R value integer argument. So as I told, std forward is used inside the template function for passing the arguments while retaining its valueness of the argument. For checking that, we have a forwarding function. It's a template function. It will take a template argument. Inside that, we will call this fun function. So this is the normal way we are calling a function with its argument. Simply passing the argument to the function itself. Here in the main, I'm calling the forwarding function with two scenarios. One is with an R value and another is with L value. Here I'm passing an R value 5. It's a literal. But we got the print like by simply passing L value. It means this function is executed. But actually we have passed an R value, but it is treated like an L value. Why this happened? This happened because even though we pass an R value argument to a function, inside the function, this R value argument will have a name. It has a variable name, so it can be identified. So from this point onwards, that R value argument will be treated as an L value. So that argument lost its correct valueness. It's treated as an L value. That is not expected actually. So let's see what is the solution to retain the valueness of the argument. Here comes std forward as a solution. So Here, inside the forwarding function, I am calling the fun function with std forward. Std forward is used for passing the argument. Let's see what is the output. See, the output is via std forward by rvalue. It means this function is executed. Our value version of the fun function is executed. This is the correct result, right? Because we pass an R value, so its corresponding function overload is executed. So that argument is treated as R value only. It has retained its valueness. STD forward can do this. It will treat an R value as R value and L value as L value. Here it shows the output with the std move. This is expected, right? Because an std move simply convert an L value to an R value. So output will be std move by R value. So the next scenario is when we pass an L value to the forwarding function. So here we are passing an L value to the forwarding function. Let's see what is the output. See here std forward prints by L value, means this function is executed. L value version of the fun function is executed. So an L value is treated as L value only. std forward has retained its valueness. That is the use case of the std forward. It will retain the valueness of a template function argument. It will treat an L value as L value, R value as R value. I think now it's clear what an std forward is doing. That's all for this video. Thank you all. Bye.